Hi, I'm Philip, head of DevRel at Flare, and today we'll see which path we took at Flare, how you can secure these communications cross-chain, how you make sure that the multitudes of chain and data sources outside of your chain that you're connecting are secure by pretty much leveraging the validator set you already have. Well, you might A, already have it, or B, you might need to acquire it by becoming an L1 yourself. It takes some work. It's not that cheap, but at the end, it can give you much stronger security assurance, and it gives you, as a protocol, as an infrastructure developer, much more freedom to make sure that your cross-chain communication, that your communication to other data sources and the underlying interface with which you're working, which is data, the underlying abstraction can be made much more powerful so that you can do a bunch of stuff on top of it. So why do we want to do this? Well, why do you want to communicate with some other stuff? Firstly, nothing lives in isolation. Neither dApps, nor chains, nor protocols, not even the front ends in today's age. And each thing has to specialize. So gone are the days where you have a chain that does everything for you. It's either too expensive, it doesn't have the necessary data, it doesn't have liquidity, and most importantly, without specialization, you end up in situations when you have developers doing something, developing a protocol, bringing people on, and just at the moment when your protocol is about to explode, when you get enough people on it, you find out that A, the chain can't support it, the gas fees are too much, or B, that the stuff you can, whatever you can do on Ethereum, for example, is just not clear-cut, not good enough to make your app performant. And this happens at the point when your app is pretty much starting to get successful. So you have to change everything. So this is why specialization is the key. And moving information across chain to enable this specialization on different chains, on different protocols, on different technologies, even on different languages or on different paradigms is crucial. And yeah, dApps need this, protocols need this, and everybody needs this. So what you want to do is you want to A, interact with other chains, you want to cross the bridges, and B, you want to make this as secure as possible. So one of my hot takes, and I'll probably say this a few times today, is A, security is like insurance. You don't need it until you really need it. But when you need it, you're screwed if you don't have it. So you should be willing to pay a bit every time you do something to make sure that stuff is really secure. Otherwise, you'll get complacent, and otherwise you'll get attacked at the point when it's really going to hurt. And you're not going to get attacked until the value at risk is high enough for somebody to do it. So you won't even spot your security problems until you really need to be acting upon them. And also, one other thing you wish to connect on blockchains, and we're seeing this more and more, is you want to connect something that's outside of blockchain space. You want to connect external world. You want to connect something you can build RWAs on top of it. You want to connect something you can settle trades. You want to connect information about people, and you want to connect AI models. You want to connect off-chain computation. You want to connect huge amounts of data. You want to connect computations on top of this, gather something from it, and move just specific pieces on-chain. And the easiest way, or at least how we tried it, how you can solve this is to say, okay, so we're not going to think about multi-chain connectivity as a specific case. We're going to think about this multi-chain connectivity as a specific case of a chain as a data source. So what we did, we said, okay, let's connect data to our chain. Let's make sure that our chain can distribute data among other chains, between other chains, Web 2, Web 3 sources, and then build cross-chain connectivity on top of this. So treat this as a full data problem. And that's what we did. So you can basically distribute your data into two different buckets. The first one is probabilistic data, prices, weather data, gas oracles, stuff like this. Data where almost good data is good enough. So for Bitcoin, well, it's falling now, but $87,000 or $87,000 and a cent, both of those things are good enough for a Bitcoin price if you can say, okay, I'm going to execute something on top of this. So as long as you're close enough, it's good. So that's one type of data source. The second type is deterministic data, something that you need to be fully sure on top of this. And for cross-chain connectivity, that's exactly what you want to have. So you want to have a precise queries about a data point resides somewhere else. So it resides on Bitcoin, it resides on XRP Ledger, it resides on an EVM chain, or it resides on a Web 2 data source. So let's say I want to have a precise piece of information. Please, somebody else, an oracle in our case, go to a Web 2 data source, go to some API, go to weather API, go to the web page where government is publishing CO2 coupon price, go there, gather the data, post-process it in a specific way, and once you do it, put it on-chain. And what you want to have here is assurance that if multitudes of your data providers do this thing, they get the same result, they can attest to it, and then they can push this on-chain and allow you to use this later. And that's what we did. So what you can do with this is say, okay, so communicating with an external chain is pretty much the same. What I'm going to do is I'm going to say, okay, have your own RPC. Please make this specific call for me. Are you observing this on XRP Ledger? Are you observing this specific Bitcoin deposit on Bitcoin network? Well, thank you. Let me know more about it. Let me know the full data source, the full metadata, and push it on-chain. And what this gives you a unifying way of asking questions about something that's not on your chain, getting this to chain, and once you're on chain, on a smart contract chain, or if you can relay this to some other chain, what you do is you pretty much are unlimited in what you can do. You can execute on top of this data by leveraging the things that blockchains do the best. So execute on this, get access to users, and distribute the rewards or payment depending on what has happened somewhere else, without having to deal with this multitude of data and computing this on-chain. And this is how you do the external chain communication. And I'll just briefly touch on how you can do this bidirectionally if you properly leverage all the tools that you have. So one thing you have to think about is bad data. As soon as you're connecting multiple data sources, and as soon as you're connecting this to a specific thing which aggregates stuff on top of this or which executes something on top of this, you have to make sure that all your developers and everybody working on this, and even you when designing the system, are sure that those transactions in between these interfaces have correct things. So if you have bad data and put it on chain, you can't roll back a transaction at a later point. If you put bad data from Bitcoin on some EVM chain and execute a reward distribution, it's over at that point. You can't roll back a piece of chain and say, oh no, the oracle was mistaken. So you really need to be sure that you have the protocol set up in such a way that this is done correctly. But there's another case where waiting is bad for a developer experience. What we did in our case, we erred on the side of caution and say, okay, so we're going to make really, really sure that bad data never happens to be on chain. We're going to be really strict with the security guidelines here, but still allow protocols to configure a bit of security when this is possible. So for example, one big thing is when you're bridging from Bitcoin to an EVM chain and you say, okay, has this transaction happened? There's a huge question you have to ask yourself, which is, okay, what if the Bitcoin network forks? Should I redo this transaction? Should I say, okay, this transaction hasn't happened, please try to revert it? So what we did is we imposed the strict deadlines of having to have at least 6 blocks, 7 blocks, and so on. But developers can choose this, and it's up to them to configure their security perspective and what they can do. Okay, so the security part. How do you do this? Well, with a layer 1 on purpose. So the main idea is that we're using the validator set. So the people producing blocks are also securing the data protocols, the FTSO, the probabilistic data source, and the FDC, the deterministic data source. So the validator set is doing multiple things at the same time. So A, they're building blocks, and B, they are also contributing to these data sources. So every question you ask is not answered by one specific validator. It's attested to by the whole set of validators and put on chain in the block that follows the next epoch after this question has been asked. Why this? Well, the main idea is to have the same security assumptions for both your block producers and for both the data you have on chain. So everything is secured by the same value. So if somebody were to tamper with the data, it would be the same amount of stake they have to acquire to either change the blocks or change the data. So you want to make sure that the minimum of those two is as same as possible, preferably equal, this way allowing you to have a nice long chain of your security assumptions the whole way how the data comes to your blockchain, and making sure that there is no weakest link. So that's why you have to use the validator set at the end. If you want to have data as secure as your blocks, well, the validators have to be including this. And on top of this, you can build a bunch of different protocols fueling DeFi, fueling pretty much everything. So you can do restaking, you can do liquid restaking. It's easy to issue tokens. And as an L1, if you want to properly do this, it's much easier to be creative. It's much easier to make sure that the data you're provisioning is good. And it's much easier to make sure that the validators are not doing something funky. It's much easier to set up your rewarding system in such a way that validators without providing good data are not rewarded enough. So bootstrapping this took quite a bit of time, but it has proven worth it because we were able to achieve 95% consensus on those deterministic data points in just a month after we started rolling this out. But still, the main idea is you have to have state, you have to make sure that building blocks is the same as building data on top of these blocks. Okay, so bundling the role. So we currently have about 100 validators on top of the chain, and the validators are not called validators anymore because the role is bundled. We call them entities, and entities derive their power to influence block building, their power to influence questions from those deterministic queries, and their power to influence the prices they gather through the FTSO by their stake. Sure, people can delegate to them, but the main idea is that gaining entry to the system is still relatively easy, is still non-permissioned. Anybody acquiring a large amount of stake can do it, but gaining a huge entry to push the system down would require you to get too much stake and would require you to get enough stake to break the system down by pretty much falsifying the blocks. So that's the main idea. The validator set allows you to answer questions, and the validator set allows you to build blocks. So bundling this role gives you much more powerful experience and much more secure way of transporting the data through. And yeah, once you're at that point, you start asking yourself, okay, so now we have data, now we have secure data. Can we do this more powerfully? Can we do this a bit better? Can we do this with a bit more power? And can we offload even more to secure environments? So which kind of data do you want? Well, you want almost all kind of data, but there's usually some post-processing involved. So you want to have some computations done off-chain by either validators or in the future upgrades we're doing by trusted execution environments. And you want these computations to be expensive. You want these computations to do as much as possible. You want these computations to be able to access data that is secure, that is maybe private, that has to be protected and has to be hidden from the public. But at the end, what you need on blockchain is just a simple result. So what you're doing again, you're offloading a huge piece of computation to the validator set. You're offloading a huge piece of computation, data gathering, decryption to a validator set, having them compute something, and use chain to store just a piece of this checkpoint. Just store me the rewarding mechanism. So if we're talking about a restaking protocol, you can have an AI model that computes everything off-chain, that aggregates all the different data from different blockchains, see how this has to be distributed among the different restakers, and then just push a small Merkle root, for example, or push a list of people that are deemed to be receiving validator rewards, push this to chain, and that's it. Why is that good? Well, you can work on confidential data. This allows you to partner with law firms and say, look, we're working on your data, we're running your specific model, we're running it on your data, and you can be sure that this is not exposed while still having all this nice assurance of blockchain for the final result of the computation to be available to everyone. And again, you also increase the performance of the whole chain because you can now not only offload huge computations that are private, you can also offload computations that are crucial to the performance of the blockchain itself. You can offload protocol-based computations to validators to do them off-chain and just commit to them on-chain. So these are so-called entities. So like I said before, they validate blocks, provide all the data points, and crucially, they're bundled together and bundled under the same stake. So we're making sure that doing one thing entails doing the other thing, and the same thing is secured by the same stake. It's a generic protocol, so we've made it as adaptable as possible. So it's a plug-and-play system. So we already have 2 oracles plugged in, and now we're plugging the third one in, where pretty much you can offload your computations to TEs. And the main idea is that by having this validator system, this entity system on-chain, you have access to a so-called set of signatures, which allows you to easily relay this to any other chain as long as you have the ability to relay those signatures on. So you have data, you have secure data, and you have information about how this secure data can be relayed to any other chain. And this gives us this cross-chain connectivity and bi-directional communication without having to adapt any other chain to this. A chain can receive this passive information without having to be adapted in any way. So information bridge like this, so going through a single chain, even for non-smart chains, and the FDC consensus, and maybe just a few things. So what this currently powers, so-called F assets, you can safeguard vaults on other non-smart chains, you can execute transaction, you can have protocol managed wallets, and you can do this very efficiently. And then since you have this data on smart chain, you can pretty much do whatever you want with it. Okay, that's it. Thank you.